Yeah. Okay, so can everyone see my screen now? Perfect. So today I am here to discuss about smart contracts and especially smart contracts on Bitcoins. Before I actually start this topic, I want to know how many of you has write smart contracts out of Bitcoin, not including Bitcoin. For example, Ethereum, ZK Sync, any other chains. How many have you write smart contract? Can anyone have already done so? Electronically raise their hands. 1, 2, 3, 4, 5, 6, 7. Yeah, that's a number 8. Wow. I see the Cohon getting more and more technical.
Yeah. And some of them might be there's couldn't raise their hand in time. So I would probably pick the number at
Yeah,
12. Okay.
more and more tech
Yeah.
guy are joining the
12 to
Cohon
15. Yeah.
space.
Yeah.
So that's great. That's great actually. The as you might know, or maybe you don't have any idea of this, but smart contract on Bitcoin is far away from smart contracts from the Ethereum side for one simple reason. Ethereum is designed for smart contract. Actually, after Vitalik was a huge Bitcoin fan, I think he still is, but he recognized one thing that Bitcoin, back to his time, Bitcoin is fully designed for transaction. By transaction, I mean not the complicated transaction, only transaction that I send you Bitcoin. That's all the transaction Bitcoin is designed for. It's more considered a cashless payment system rather than anything smart or application. It's far away from the Ethereum design nowadays we're familiar with. So that's the problem of Bitcoin, and that's the original idea of Ethereum. Vitalik saw this fact, and he think, okay, that might be cool. If we can create something that can run programs, that can run applications while we keep it decentralized. And that's the original story of Ethereum. So we start saying that Bitcoin is not designed for that. Bitcoin is fully designed for just make payments at the beginning. That is to say, all the days, all the technology you have on Bitcoin, it's very difficult to build smart contracts. You can you just follow the Ethereum 101. They will teach you how to build smart contracts on them. There is already a lot of YouTube videos, a lot of the 101 touches or a lot of use case on Ethereum. So you can pick up very easily. But now you're on the Bitcoin wall, and Bitcoin wall is totally different. The tech and the smart contract on Bitcoin side is very different from the Ethereum. So that's the first point I want to touch before I start introducing smart contracts on Bitcoins, because I just realized many engineers, we actually are hiring more and more engineers from the Ethereum side these days. And I just realized that most of them, they're so unfamiliar with Bitcoin that they didn't know we don't have a native smart contract on Bitcoin. And that's the very obviously fact on Bitcoin that you will be facing in terms of technology when you are building applications on Bitcoins. And there are many solutions. I will focusing on one major solution, that is ZK. I will introduce you with several approach, but mainly the Bison approach because I designed that, so I'm more familiar with that. But also I will touch different approach, including the OP-CAT and the BVN approach to fulfill the ZK ROAS on Bitcoin, and how do that bring us smart contracts on Bitcoin. So without further saying, I will go. I will continue the introduction of ZK ROAS. But before even like I know I already said before we touch the main point here, but before I reach the concept of ZK Bitcoin even not designed for the smart contract, but after several important upgrades, especially the taproot upgrades, we now have so-called Bitcoin strips. Bitcoin strip is basically, if you are familiar with Bitcoin, Bitcoin is composed of input and outputs, and every output you can use them as your next transaction's inputs. So in a Bitcoin transaction, the most important thing is what input you are using. That means UTXO, the last output you still have, will be your next transaction's input. And then what output or UTXO will this transaction create? That's the basic Bitcoin idea since day one. Bitcoin is a combination of transactions. And what we have nowadays is that we used to only have a signature controlled input that you only providing your signature to unlock an output to use as an input. But for many reasons, for example, to achieve the multi-signature and to achieve time lock, for this kind of reasons, we have introduced, or Taproot upgrade has introduced a very simple but still very useful and powerful system that is called Bitcoin strips. So today, most Bitcoin outputs, they are not longer controlled by a simple signature. They are controlled by a set of strips. I believe later on, Super Testnet might be in this call and talk more about the Bitcoin strip. I will just touch the point today, but that's one major features. And basically today, all the layer 1 technology or anything for those true layer 2s, we are working inside of these strips. Later on, I will touch BVN, OBK, and our solution. All of them, we are relying on the Bitcoin strip features. Yeah, that's finally, that's my before I enter the main point, that's what I want to say. And let's go to today's main topic, ZK ROAS. So ZK ROAS is not only limited to Bitcoin. ZK ROAS is actually already a very popular design or agricultures of ROA designs on the Ethereum side. And ZK ROA are very popular these days, right? We already have ZK Sync, we already have Scrolls, and we have many other ZK ROAs already working perfectly, including Starknet on the Ethereum side. And what they do usually is that they bundling multiple transactions off-chain, and then it will generating a simple proof, one single proof, to prove all these transactions that happen off-chain, they are valid, they are legit. And this could be also included into the main chain. In most cases, this main chain means Ethereum. And then by this way, they can spread the trust list feature on the Ethereum. But you don't need to pay the very high Ethereum gas fee. You don't need a Ethereum node to tell you that this is true, this is not. You don't need to directly interact with the Ethereum node. You simply running off-chain, and while you are running off-chain, it will generating so-called a ZK proof. And later on, this ZK proof will be submitted to the layer 1 chains, in most cases Ethereum. And then a smart contract that is set to Ethereum will verify this ZK proof. By verifying this ZK proof, they will be confident that all the ZK proof transaction that is being bundling off is valid. And then this change of statements, this change of states will be considered valid on the layer 1 too. So in this way, we can reduce the cost of transactions because all these transactions, they actually happens off-chain. They don't necessarily being on layer 1, but still we have the trust list features on layer 1. So ZK ROA is also usually being considering an agriculture that achieves high throughputs and scalabilities, but at the same time, we minimizing the on-chain data, but not losing the security. That's the solution to the triangle dilemmas to blockchain. But as you might notice on the description of a traditional ZK or a Ethereum ZK, there is a very important step that you need to submit the ZK proof to Ethereum, to a smart contract. And this smart contract need to verify it. And after it's being verified, then you can be considered finished or fulfilled on the layer 1. Unfortunately, we don't have smart contracts on Bitcoin. That's one very big challenge that we don't have. So how we achieve that on Bitcoin? That's some topics. Or nowadays there are 3 paths that we are achieving this in 3 paths. I will first introducing the Bison path, but later on I will also have a touch about the BVN and the Startnet team. They are Eric team, Ted routine. They are working together to introducing the OPCAT test too. So let me first of all let me shortly introduce how we are doing on Bitcoin based on our assumptions. So Bison's assumption is that it's very difficult to change Bitcoin because Bitcoin is a very fundamental coins and it has very, very high values. It's controlled by miners. It's fully decentralized. It's controlled by those mining machines. So they are earning, you can imagine that they are earning billions of dollars every year. And they would not easily to take that risk because they are already rich. They are already very huge. To then maintain Bitcoin itself is the most important thing. They don't want to take risk to change Bitcoin too much. So based on that assumption, we assume that Bitcoin itself is very difficult to improve or to introduce even more features, even though it did happen in the past. But it's very small changes, and even so, like the OPCAT actually was originally in Bitcoin by 2011, but after that they say it's too risky. They might change the nature of Bitcoin. They remove it from the Bitcoin core version to a more simple version. So basically, the Bitcoin community, by Bitcoin community I mean those huge miners and the Bitcoin core developers, they have the tendency to keep everything just what they are right now, and they would love not to change anything due to the risk. So that's one major assumption we made. And the second major assumption, so what we can use is what we have. We don't have anything that is not currently on Bitcoin. And the second assumption is that we believe in user side. So we have so-called sovereign layer. That means our users, everybody who is using Bison, we encourage them when they install the wallet, we encourage them to use a Bison Empower wallet, and this wallet will not only do the original wallet, a typical wallet like MetaMask or Unisat. They keep your private key and they broadcast, they connect it to a full node or one of the nodes, and they broadcast your message. That's what they do. But in our design, our wallet stays more works as the verifier. Instead of being verified on the Bitcoin nodes, our users will verify the ZK proof that we write into Bitcoin. You still don't need to directly interact with us. You just need to interact with Bitcoin. But on Bitcoin, we provide the data that necessary to prove Bison's sequencing is correct. And we write the data to Bitcoin, it be fetched by our users, and our users verify them later on. So we can pass the trustless functions in this way via Bitcoin to our user, to our end users. So we can have an agreement that the Bison block is valid, is legit, only while you are only interacting with Bitcoin. That's the way Bison are doing. And what the Eric team, what the Taproot Wizard team, they are doing is that they believe Bitcoin can be changed, even it's challenging. So they are pushing to have more functions on Bitcoins, on the Bitcoin strips. They try to add back the OP-cat. OP-cat is actually, even though it contains the cat names, it has nothing to do with the animal cats. It's more like a copy. You can copy some data from an earlier object, and then you can pass it on behind of existing data. So you can move the data from somewhere else and add it up here. That's how OP-cat works. And it is important because now Bitcoin strip don't allow you to do so, and that makes having a complicated. Just imagine that you cannot. You have a fixed number. You have a fixed number of data. For example, address is 64 bits, and then you only have 64 bits. You don't have anything longer than that, which the OP-cat. So it makes it very hard to program very complicated data or complicated programs on Bitcoin. But with OP-cat, it will be way easier. So with OP-cat, it might be possible that have a verifier, a true ZK verifier directly on Bitcoin as a strip. So Bitcoin nodes will do this, and that means that you can lock in a lot of the Bitcoin fundings into one output, and this output reflects the layer 2 transactions, and by input that you can have a very trusted and let's say Ethereum like layer 2 bridges. But the difficulty is that OP-cat is not live yet. And yeah, they have made some progress. They have the OP-cat, they have achieved the OP-cats on the SingleNet, I think. But SingleNet is far away from the mainnet. SingleNet only have 40 or 50 major mining machines, and that numbers means